Hey everyone, here's another example video from section 3.3. They want us to find the first and second derivatives of this function y equals 5x squared minus 10x minus 9x to the negative 2. So I'm going to find the first derivative to start with. dy over dx equals, well, not equals, of this function. So we're going to say 5x squared minus 10x minus 9x to the negative 2. Again, we're going to use the difference rule. So I can say that dy over dx of 5x squared minus dy over dx of 10x minus 9 minus dy over dx of 9x to the negative 2. Should probably put all these in parentheses there. Very good. So then I want to say that dy over dx equals, and I find my derivative here, so I bring the 2 out front, so that ends up being 2 times 5, which is 10. And then I reduce my exponent by 1, so that's 10x. And then this one here, the derivative of, really remember I can bring the 10 out front. Derivative of x is just 1, so I end up with just minus 10. And then on this one, the negative 2 will come to the front. So I end up with negative 18 here. But I want you to see that I end up with minus because of this negative sign. That'll give us negative 18. And then x to the, I go down by 1, so negative 2 going down by 1 exponent, that's a negative 3. And then I need to write that as 10x minus 10 plus 18, right? The negative and the negative, x to the negative third. So that's my first derivative. So let's find the second derivative. So we have let's see, second derivative of y with respect to x of this function, 10x minus 10 plus 18 x to the negative third. Again, we're going to use the sum and difference rules here, and we're going to say that that equals second derivative of y over d of x squared, 10x minus d2y over dx squared of 10 plus d2y over dx squared of 18x to the negative third. That's going to give us for a second derivative if I take the derivative of 10x, I just get 10, right? The x just becomes a 1. If I take the derivative of a constant, we know that becomes 0, so I end up with, well, you could say minus 0 or plus 0, whatever you want to say, so just plus 0. And then finally, the derivative of this last term, because I have a plus there, I'm going to get plus, and then negative 3 comes out front. That's going to be negative 54. X, go down by 1, that's negative 4. So I end up with 10 minus 54 x to the negative 4. And that's my second derivative for that function.